Alrighty, guys. Good afternoon again. This is part 2 of lesson 6.3, multiplying monomials. So to quickly review, I'm just going to review one thing. This is 6.3, multiplying monomials part 2. Okay. You will have a quiz on Friday that's scheduled. So be studying, be prepared, because I'm not there to answer all your questions, unfortunately. But if you're having an issue, you can rewatch these lessons in your own time. They're on YouTube, so you don't have to you so you don't have to ask the sub to send them to you. They're on YouTube. They're going to be on YouTube, so you can watch them. So to quickly review 6.2, we talked about the product rule for exponents. So we talked about the product rule. Product rule. What's the product rule? Well, when we have two numbers or even two variables multiplied together with different exponents, you're going to add those exponents together and you're going to carry the base, okay? Key word I want you to learn is base, because the base could be a number or it can be a variable. And I don't want you to confuse the coefficient with that variable to be part of the base. So if I have 2 to the second power times 2 to the third power, we know that it's 2 to the fifth power, okay? We also know that x to the second power times x to the second power is x to the fourth power. Should have kept it 3. You know what, yeah, I'll do that. So it's consistent. If you already wrote down, I'm sorry, but rewrite it down, just so it's consistent. Okay, now we're going to combine the two, where it's 2x to the second times 2x to the third. I don't want you to think, well, they're both 2x, so then it's going to be 2x to the fifth. That is incorrect, okay? Sad face. No, that's not what it means. Now that there's a coefficient, you multiply the two coefficients, which are 4, and since they're both x, we carry the x, and we add the exponent, which is 5, okay? I want you to write this down. Please write this down, okay? This is going to be here. And that's the product rule. Quickly review. Moving on, we're going to go into power rules. Okay, I know it's a little confusing because we just went over product rules for exponents. Now we're going to go into power rules for exponents. So, power rules for exponents. Power rule for exponents. Okay, here's power rule number 1. Rule number 1. When we have a base with an exponent inside of parentheses, this equals, and there's another exponent on top of it. You are going to distribute it, okay? Um, when it comes, no, I'm not gonna. I'm not gonna try to explain it more because it's gonna confuse you possibly. Um, it means it's gonna be m times n. So let's write an example, just so for your sake. We have here, let's say, um, we have 2 to the second power to the third power. Okay. We're going to keep the base because that's how it shows. That's how it's shown. And we're going to multiply the 2 exponents. 2 times 3, 6. And that's your answer for rule number 1. For rule number 2, uh, when there are several bases inside a parentheses with an exponent on outside of it, Mr. Polito, why are we dealing with letters? I'm tired of seeing letters. I know, and me too. But these letters are just a skeleton of it. Um, and you're not going to see letters hardly ever, other than X and Y, well, and Z. But in this situation, we're using letters because it could be random numbers, like kind of like how we did here, where we, you know, where it makes sense when we put numbers to it. It makes a lot more sense. That's why I wrote rule number 1, what the rule is, and then I wrote down with actual numbers in it, so that it wouldn't uh, confuse you. And so here, I'll change the color as well. Now this one is blue. They're not like that. Okay. Oh, it's not the correct type. It's not the correct red. My OCD is kicking in, so now I have to do this. I committed, so now, now I have to commit. There we go. I gave you an example to it. So, rule number 2, we have A and B, 2 bases together. Uh, okay, 2 bases together with an exponent outside of it, and we're going to distribute. Uh, Essentially, that's what it's done here. The n is being multiplied to the m. Same thing here. You know what? We'll keep that arrow there. Okay, and that's what it means essentially. It equals a to the n and b to the n. That's just what it means. So if we have, for example, we have use blue. If I have here 2x in parentheses to the second power, it's going to distribute, and it's going to equal down to 2 to the second x to the second. Moving on. Let's go ahead and do something with rule number 1. Sorry that I'm taking my time with this. I'm looking at the textbook, and I want to make sure that I don't write the wrong thing. So let's go ahead and go back to rule number 1 and do a couple examples. So we have rule number 1, and we have 3 to the 4th power to the second power. So we know that it's essentially going to mean 3 to the 4th times the 2. And then 4 times 2 is 8. So it'd be 3 to the 8th. And 3 times 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 3 is 6,561. Okay. I want you guys to write exactly what I'm doing. So I started with this, then I moved on to that, and then to this, and then to that again. So please make sure. I want you guys to get in the habit of showing your work, because sometimes you don't show your work, and I don't know what you did. If you show your work, if you don't show your work, I don't know what you're doing. We're doing something else, something totally different. Uh, as well, you could do this as well for those that want to do things differently. We got, so I'm gonna copy this, so I have to rewrite it. What's 3 to the 4th power? What's 3 times 3 times 3 times 3? Okay, it's 81. Okay, but because we still have this to the 2nd power, we have to carry that over. So then, what's 81 to the 2nd power? 81 times 81, 6,561. That's two ways you can do it. I would probably, I'm not too sure which one I like better. I think I like this one better, but this one might be easier to do in your head because you're doing smaller pieces. So instead of doing 3 times 3 times 3 times 3 times 3 times 3, you could do it fast. Okay, 3 times 3 times 3 times 3. Okay, 81. 81 times 81, 600. 6,561. So whichever one would be okay. I think I'll take about either one. But understand rule number one. Um, let's go ahead and do another example. So this is example number one. Uh, example number two, I guess, and then example number three. And we have x to the 5th power in parentheses to the 3rd power. Okay, so again, we're only dealing with one base here, so that base is going to carry over. Um, now remember, yeah, there's only one base, so that base is going to carry over 3 times 5, because that's where I got those numbers. Okay, what's 3 times 5? 15. Good job. X to the 15 power. That's your answer. Uh, so far, so good, guys, right? You're getting the hang of it. If you're having an issue, please do not hesitate. Um, you know, to you can have the sub replay the video for you. Uh, pause if you need to, so you can have everything written down. So let's go ahead and move on with rule number 2. And let's go ahead and write the rule number 2, power rule, not product rule, because that's a different one. The product rule is A and B to the A power, to the power of A, equals A to the power of A and B to the power of A. I know it's hard with looking at random letters and, well, isn't math having to do with numbers? No, math is not only about numbers. It's about letters. It's about processes. It's about sometimes even logic. So that's math. Okay, it's not just strictly numbers. Let's move on. Let's go ahead and example number one. We have 3 examples. So example number one is negative y to the 5th power times 2. This one, when it comes to negative numbers, it's special because what do we know about negative y? There's an understood what? There's an understood 1. Exactly. So, although there is one base visually, looking at it, it's only y. So it's just negative y to the 10th power. No. Um, because there's a negative, there really isn't one base. There are two bases. So it would be, and so here you're going to distribute, okay, and let's pretend there's a negative 1 there. So we would distribute to both of those. So then it would become negative 1 to the 2nd power and y to the 5th to the 2nd power. Okay, and we know that it would be, we know negative 1 times negative 1 is positive 1. And then these need to be multiplied together and we get y to the power of 10. So then it'd be y to the power of 10 or just y to the power of 10. I mean, yes, you get 1y to the power of 10, but essentially it's just y to the power of 10. Okay. If you leave it at 1y to 10, it's not a big deal. I'm not going to give you it. I'm not going to fail you for that. But uh, it's very important when we have a negative number. I mean, not a negative number. When it's negative y, it's very important to you to do that. Because if it was just y, if it was just y to the 5th, then it would have just been y to the 10th. You know, um, well, we got the same answer. So why does it matter? It matters because if the exponent was 3, then it would have not been negative. Um, it would have not been y10. It would have been negative y10. Because remember, and here's this we're gonna sidetrack for a bit, okay? Mini lesson, okay, or well, for not really mini lesson, more like mini review, okay? Mini review. I want you to write this down, okay? Please write this down because you're gonna need it. Um, when we have an even number of exponents, our answer is positive. Okay. We know our even numbers, right? 2, 4, 6, 8. Yeah, we're going to end with a positive. When we have an odd number of exponents, our answer is negative. And that's why it's so important. That's why it's so, even if your number is a negative, even if it's negative y, I still want you to break it apart and carry that exponent over like how we did here. Um, oh, I just realized, yeah, the exponent, the 5 does not distribute, the 2 distributes, okay? I hope you caught that, and I hope you didn't write that down. If you wrote that down, please fix that. I'm making this lesson as you can see over here, um, it's 4:17 on Friday. Okay, it's been a long day today, so if I mess something up and I don't mean to, I'm sorry. But yeah, so remember that even number of exponents positive, odd number odd number of exponents, your answer will be negative. So I don't want you guys to mess up. So okay, moving on. Second example. We're almost done, guys. We just have two more, and we'll make them quick because I want to be done too. We got example number two, and the example number two is negative negative m to the third inside parentheses to the third power. So same exact thing. We're going to distribute that 3 into the m3 and the negative. You understood 1. So let's go ahead and write that down. So it'd be negative 1 to the third power and m to the third power to the third power. Okay, I know hearing it sounds crazy, but when you look at it, okay, it's not that bad. It's not that bad. Okay, and so we did that. So that we know that looking at our review, an even number of exponents is positive, and an odd number of exponents is negative. Since we're dealing with 1, the answer will be consistently 1. But what kind of 1? Negative 1. Okay, so then we know that these are going to be multiplied together. Uh, so let's just go ahead and do that now. You can rewrite it like how we did here. Um, no, I didn't rewrite it. In the book, it makes you rewrite it like twice, and I don't think you need to. I don't think you need to write, m to the 3 times the 3. I know you know how to do it. So then, and we have and what's 3 times 3? 9. So our answer is, uh, you could put negative 1 m to the 9, or you could just leave it negative m to the 9. I wouldn't mark it wrong if you put negative 1, but you would want to do it this way. So that's example number 2, and then we're just going to do example number 3 and call it a day. And this one's a little not trickier, but it's a little bit more lengthy. So we have 2x to the second, y to the third, in the parentheses, to the third. Okay, so guys, like I said, it's very important to show your work and to break it down in pieces. And please, for the love of Jesus, for the love of God, for the love of your family, for the love of your friends, for the love of your teachers, first and foremost, for the love of God, please show your work and make it nice and neat, because some of you guys are doing work over here, 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 and then like eventually your answer is like right here. Okay, and it's hard for me to keep track. So please keep it nice and neat. So what are we gonna do? We're gonna distribute to each and one of these terms. Okay. Um, so let's go ahead and do that. We have 2, okay, but in parentheses just so it's consistent. 2 to the third, okay, what do we have? What's next? X. Okay, we got x to the second, okay, because that's what it is, to the third. And then we have y to the third as well, okay. So now we can go ahead and solve. So then let's go ahead and break it down. So we got 2 times 2 times 2. 2 times 2 is 2. 4 times 2, 8. Great job. Then we have x to the square. Okay, we know from exponent rule number 1 that we just multiply these. So what's 2 times 3? 6. So it'd be x to the 6th power. Then we have y. Okay, it's only y, so we're going to carry it there. What's 3 times 3? 9. Okay, so your answer is, I know this is your answer, but it's too spaced out, so we're going to rewrite it. 8x to the 6th, y to the 9th. And that is your final answer. And that is it. That is it for 6.3. I did it in 2 parts because I think it was a little bit, it's a lot to go over. So here, this is the first part of it, if you want to pause. And here is the last part of it, that mini review, and then that problem number 2 and problem number 3. And that's it. Your homework, your sub will tell you what the homework is. I told them and I gave it to them. So uh, that is it for this lesson. Thank you guys. Have a good day. I I know you guys miss me. Okay, I know you do, and I miss you guys. I care about you guys. Love you guys. I'm praying for you guys. Have a good rest of your day.